Hello everyone, welcome to module ENG740, Engineering Research Methods and Postgraduate Studies. This is the first session that we'll be doing. Unfortunately, I'm not here, so it's a pre-recorded session. Usually if I was here, there would be a bit more interaction. As you know, this module will be delivered online as well as on campus as the time goes on. So starting off with this, we're going to be looking at what is research. So usually here we would have a bit more of a discussion within the classroom, but due to me being absent and this being a bit more of a blended delivery, we'll just carry on. I'm sure Professor Alison Macmillan will do more of an interaction with her session as she would be here and available. So what is research? So it's usually a discovery of new things that has been independently verified by other professionals. Now these new things is nothing that's completely brand new. It could be a new methodology, a new material, a new approach. It could be a variety of a new novel aspect to a known research. Or for example, if we take into account modeling and simulation, it could be a new approach to a turbulence model. Or if it was something more practical, such as materials, it could be a new approach to fabrication of composite panels. So this discovery is something that is independently verified and also by other professionals. So it's also something new to humanity, not just to you or your group. So look at the impact of this research that you're doing. So the research itself, even though it may be, very particular in your research field, but, does it have a much wider impact? Could be to society, or it could be to the community, or it could be to a much more range or variety of aspects. So the scientific method is the approach that we take, specifically in engineering. There's many, many different types of methods in research, but the scientific method is something that everybody will be familiar. Hopefully, everybody within this program, one way or another, come from an engineering background. So we have this prior knowledge. Now, everybody here, either you're coming from industry or you're coming from an academic background, we have this prior knowledge, be it your undergraduate studies or even another master's studies, or even, as I said, industrial experience, working within a company for many, many years, you have this prior knowledge. So with this prior knowledge, we have this time and opportunity to come up with an idea, looking at, what our strengths are. And this is some of the tasks that we'll be doing in shortly after this session. We develop an idea that we believe, we can contribute to the research community in order to develop something that's new, and that idea then we take forward. So this idea becomes a discovery. We need to discover and we need to look at, how this idea will work, and where it needs to go. So what happens is, we conduct a study, we do some independent verification, we do some literature review, we may even do some experiments, some numerical models, some analytical models, and we test and vigorously look into the actual idea that we've discovered, or you discovered, and we look at, what's currently being done, for this idea in terms of literature, what's been published, what's not been published, what the methods they've taken, what kind of experiments have been conducted, or numerical model simulation that has been achieved, in order to see, is it viable, is it robust, and what can be done better, or what can be taken on board to discover something much more newer, in a sense. So once you've compiled all this independent verification, which is your master's research, your dissertation, it then gets been submitted, and usually you would submit your report, or it could be a peer-reviewed publication, which goes to a journal or a conference paper, and once that's been submitted, it gets then assessed. For example, your dissertation will be assessed by your supervisory team, your primary supervisor, your secondary supervisor, and also external supervisors or external examiners in your case from other universities. The same goes for peer-reviewed publication. So once you write your paper, it gets submitted to a journal. The journal editor then reads the paper. He or she then may say, okay, this is good for the actual journal, and then they pass it on to 5 reviewers in most cases. And those reviewers will then go through your documentation, the research that you've done, look for any flaws, any holes within the research, and they will then give their comments. So they, again, as I said, will look at your independent verification. They will look at your literature, assess your numerical models, your analytical models, and the outcome is recognized as a major contribution to the field. So, for example, your dissertation would pass, and that becomes a contribution, or your paper, goes through the editorial scrutiny, and then that again becomes a major contribution to the field of study. So the research community, as I have stipulated, this module has a very, very wide range and mix of students, going from mechanical manufacturing, aeronautical, all the way to unmanned air vehicle systems. And we've also got different modes of study. We've got people who are coming straight from academia. We've got students who are coming from industry. And we've already got students who may be doing industrial projects that they've already secured, specifically back in Germany with industry, where the project has already been provided to the students. Nevertheless, it's very important to understand who your community is. So, for example, a mechanical engineering student must understand who their community is compared to an electrical and electronic engineering student. So one thing is standard, no matter what your discipline is, we need to make sure that they all use the same scientific method. They all follow the same ethical principles, and they all use the same language and terms. However, a mechanical student, for example, say the Journal of Mechanical Engineering, the language and terminology used in that journal will be completely different to a journal that's more prescribed to electrical and electronic engineering. However, there is some crossover, which is the scientific method, the ethical principles, but however, the language and terminology may differ depending on the different journals and the different categories of disciplines that you may be looking at into. They all provide information to the worldwide community, reported in a full or open manner, and they all acknowledge the previous work of others, which is very important. So these are the research community, where you may find from peer-reviewed publication. It could be other institution, organizations, industry, universities, research organizations. So again, it's very important to understand where the research community is. So publications and referencing is where the research gets published and where the outcome is. And this is going to be one of the first things that you will do, is to understand, where and how to obtain the publications for your referencing, because they'll be the building blocks of your research. So the one thing is that the literature must be printed somewhere, and it must not be changed or alterable. It must be reviewed by independent professional before publication. So there are lots and lots of publications, should we say, that are online that are not accredited, hence meaning they're not really with a journal anyway. It's just somebody that has published something online, but it's not really associated with any sort of journal. So there's no professional independent reviewing being done. So some of the key things that we want to be using is things like Google Scholar, Science Direct, Elsevier. Those are the kind of sources where we know 100% that they're Scopus related, meaning that they are accredited from a journal which is being published, and must be complete so others can reproduce the results. So no matter where you look in the journals and the peer reviewed publication, it should have the whole process, i.e., for example, how it was generated or how it was fabricated, what was their method that was used. And in order for someone to be able to replicate their research, in order to achieve very similar results or use it as a validation, or even look at it to identify alternative opportunities in order to look at different directions of the research. So the types of publications, there's scientific papers, trade articles, newspaper articles, infomercials, advertisements. There's many, many different types. But one thing that as postgraduate students, and specifically at master's level, we must only rely on referenced papers in accredited journals and conferences. That's the ideal place. There are other kinds of publications that you can use, such as, for example, Wikipedia, or there's a few other online sources that you can use. But depending on your chosen research idea and the way that you want to go, I would strongly recommend finding most majority of your peer review publication and your references from accredited journals and conferences. But just to emphasize, there are some students who are doing industrial projects, and it may be very difficult to find publications related to the topic that's provided by your industry. You can then therefore use internal documentation from the company. As I stated, that if it's an industrial project, there will be a non-disclosure agreement signed where everything that you do will not be available to the public. So it will be only included by the person who signs the non-disclosure agreement, yourself and the company. So how can you tell in the beginning what is a good publication or what is not? So here's a few things that you can identify. So the length of the title. So it's always moderate to have a look at the length to see if it's either too long or too short. It just gives you a good indication. Their references and the quality of their references. So as I said before, if you find a paper where you see all 25 references are basically web links, then that's not very good. Or you see a number of references in their publication that's actually from one research area, for example, or one research source. Also, looking at the quality of their references could be very important in terms of the Q factor. So journals are rated with Q factors. So Q1 being a very, very high impact factor, Q2, Q3, and Q4. Now, Q3 and Q4 are usually either very bad journals or they're journals that have just started editing. You should try and aim for Q3, Q2, and Q1 for good journals. The author's name and affiliation is very important sometimes. So by typing in the author's name, you can see how many publications they've done. Go on to Scopus, maybe type in the author's name, see what's their impact, how many people have recited some of their papers, and also who are they affiliated with. So having a look at, for example, an author who's maybe affiliated with many different universities, Oxford, Cambridge, or Cranfield, for example, then okay, their affiliation is very good, therefore the impact factor will be very good. However, if there's no affiliation or there are places that are very unknown of, it can be frowned upon sometimes. So the evidence of the paper has been reviewed and revised. If you look at any paper, you will find when was it submitted and when was it finished. So you can see the given dates. So the date of submission and the date of publication is also very important, because you can see, for example, I don't know, just say 2018 the paper was submitted, and then 2020 the date of publication. That there was a 2-year gap in between, which means that there must have been some major corrections where the editors have requested the author to amend his paper. Now, a good, date between submission and publication is usually within 6 months. So within a 6 month period, that means that there was very minimal errors within the paper, and therefore, it got published straight away. Does the paper include a review of previously published work? Very important. We always need to know that, have they done a validation? Have they reviewed previously published work in order to justify their approach and their methods? And the conclusion contains a critical reflection of the content of the article. So again, when I go through looking at publication, I go look at the title, I read the abstract, and I go straight to the conclusion to see, what kind of critical reflection they have talked about within their paper as well. So this is one way you can tell if it's a good paper or a bad paper. But when we come to a few sessions following, I believe it's going to be session 8, where we look at introduction and lit review. I will give you a lot more detail about the literature review section and how to establish this. So I'm going to provide you an activity now, and this activity has no credit-bearing marks, but it's a very good activity for you to conduct because it starts getting you to think about your master's research. But also fundamentally, the work that you do for this gives me a bit of an insight of who you are, and it helps me to support you and guide you to the best possible research project that you may be able to do and complete. So first of all, what we're going to be doing is a creative brainstorming. We're going to be looking at your past, your present and future. Now, you can do this many different ways. Usually when we're in class, we do this on paper first, and then I get you to present by digitizing it. But look at your past. So this could be things like, your education, where you're from, what your key hobbies are, your interests, any kind of qualifications that you've done, being professional, academic, or it could be simply food hygiene or first aid. These are kind of things that we want to be able to look at. Then look at the present. So what are you currently doing now? So straight away, I know that at present, everybody should be putting on they're doing their master's research, But is there anything else that you're doing? Have you joined a society? Have you picked up a new hobby or sport or new interest? And what is the future? Where do you hope to go? Are you, for people who are in industry, are you progressing to managerial positions? Are you thinking of a career change, perhaps? Some may be looking at potentially doing PhDs, or going into academia, postdoc, so start thinking about your past, present, and future. Once you digitize or put it on paper, it gives you the best starting point to move on to the next stage, which is using the available resources, start researching prospective ideas for your MSc thesis. So remember, this is a 60 credit module. So it's going to be a massive chunk of your master's studies. And also it's the only basis of describing who you are and what you specialized in. So it's very important that you pick something that reflects of who you are and where you want to go in the future. Try and obtain literature, one new and one old, published peer-reviewed publication for the chosen topic. So whatever you've decided to select for your research perspective ideas, and you could have maybe a few, you don't have to have just one. You might, in the beginning, have 3 or 4 different ideas, and, start collecting the publications for those ideas. As I said, one new and one old. Start to think about working titles for your research ideas. Title's important. It's something that defines what your project is and who you're going to be. It's also something that we work on specifically when it comes to how to write a research proposal, because a nice catchy title means you should be able to capture the attention of the supervisor as well as people who are interested in your field of study. And last but not least, write a brief description of your research idea. or ideas in this case, approximately about 200 words, and this should, include a variety of things within your the research idea itself. And I'll give you some examples in a second. So one thing that you must remember: everything you do will only add to your research proposal. So I prefer not to waste any effort that you put in. So these 200 words, these brainstorming ideas, everything that you're going to be doing, one way or another, will go into your assessment. So as we learn, we participate, and also those participation of tasks will be added to your assessment. So this is an example from Steve Davis. So he wrote straight away, past, present, and future. He did a bit of brainstorming on paper, but then he translated it. Past, what made me who I am. Present, who am I, and future, where am I going? So you can see, straight away, employment history, variety of lists there, some good qualifications. He was a banker, Microsoft certified technician, and then life experience. So he's a father with a commercial pilot, former city councillor, had 50 years of motorcycling and counting. And then looking at who he is, he's a husband, he's a father of a 27-year-old son, he's got some heart conditions, he loves technology, online gamer, and he's also a member of team. So, type 1 manager, experienced public speaker, external adapter, hard to phase, thinks on his feet, all those key qualities. But he's very unsure of where he's going. So, and that's why something like this helps me to have a one-to-one session with Steve to come up with a potential idea for his research. Here's another student who's more understanding of where he's going. So his past, he's got some A-levels, he's already got 3 master's degrees, an MEng, an MSc, and MSc Space Systems. He's got some group design projects that he's done, some research projects that he's been involved in. Currently, he's doing an MSc in unmanned aircraft system technology. He's part of the IMEC UAV competition. He's doing some individual research projects, and for his future, he already knows that he wants to start his individual small business. He wants to travel Asia and the USA. He, again, some personal stuff. He wants to fall in love, get married, the usual thing. But you may find that quite, funny at first, but it's very important that, if someone's future potential ideas is to settle down and do things, whenever you pick that research idea, if you pick something very, very stressful, very, very demanding, then you can forget about, those kind of natural things of getting married or having children, because your research will take over. One of the key things when I started doing my PhD, I attended a conference where a professor from Australia came and said, there's the 7 secrets of being a successful PhD student. And the first one was, never ever get into a new relationship. And number 2 was, never get married during your PhD studies. And it was, it was very remarkable, for him to state that. And he said he has seen so many people, so many potential research students who, start their research, PhD or whatever, and then parts of life get involved, and one can't do with the other. It needs to separate. So it's best to put everything on paper. So when you look at a potential research project that you want to do, if you've got other goals in mind, you want to travel specifically during that year of your master's research, then think about your potential research idea and maybe look at your time management plan and incorporate that into it. So just to give you an example, one of my students, an MSc student, he traveled Nepal and Asia, but the way he managed his research was unbelievable. He set all of his simulations up on a remote desktop, and basically he knew that his simulations were going to run for approximately 3 months. So he knew that's 3 months of dead time that he can actually go and travel. So he pressed start on the computer. The simulation was running for 3 months, and during those 3 months, he basically just remote logged in just to observe his simulation was up and running and going well. And then when on his return back to the UK, all the simulations were finished. He then just basically downloaded the results files and then wrote his dissertation. So again, everything is possible if you can manage and plan your research. So once you've done your brainstorm, this is an example of writing a brief description. So the project title for this one is a high throughput process for atmospheric pressure inline production of thin film photovoltaics. And this is my PhD research that I've done, and you will find throughout the whole module when it comes to writing the research proposal, we'll be using this as a main focus and topic where I'll be giving examples. So you can see this project is to investigate the thin film photovoltaic production in an atmospheric pressure inline production. The proposed project has a wide range of applications in different engineering disciplines, mainly focusing on solar panels. The achievement of high throughput process for atmospheric pressure chemical vapor deposition reactor would be an achievement for the manufacturing process of thin film photovoltaics. Thin film flows formed on the surface of a moving substrate will be investigated both theoretically and experimentally, in particular the film dynamics. Currently, there is very limited study on this topic, leaving a lot of problems needed to be resolved. Thus, the proposed project will aim to solve both the uniformity of the thin film photovoltaic and the atmospheric pressure inline production. A model of the fully three-dimensional APMOCVD will be set up, and from this, a fully functional model can be produced. So within this, statement, or this, this brief description, it describes quite a variety of things. So it talks about the necessity of the project. It even critically reviews what the project is, and it also makes some very important statements, specifically talking about, it'll be investigated both theoretically and experimentally. So we can see, okay, so there's going to be some numerical modeling here, there's going to be some theoretical application, and also some practical kind of application. But also it's stipulating that there's actually very limited study on this topic. So it's critically reviewing it, saying that, well, hold on, there's not much information on this, but we will be looking at resolving these issues. So you can see by looking at what I've done as an example, here are two other examples that students have provided last year. So we can see reinforcing 3D printed models with layers of meshed fibers, and they took the same approach by color coding and then providing two references, one from 2014 and one from 2020. And on the right you can see apply drop-off profiles in transition zones for composite fiber reinforced plastic panels. And as you can see, again, two papers, 1977, and then another one for 2020. So what I would like is everybody to do one document of a brainstorming exercise, past, present, future, so I can see who you are, look at your skills sets and where you're planning to go and some of your achievements, and then potentially a research idea or ideas with titles and references. And as I said, there's no deadline for this. What I would like is, if possible, our first session for the research proposal starts on the 11th of the 11th 2021. On Moodle assignments, I've actually set this up where you can upload. So if you've done it already within the next few weeks or so, you can quickly just upload it, and I can just quickly give you some feedback and some comments on that. So yeah, that's it for session one. If you do have any questions, you can post it on Microsoft Teams or send me a private message. Either way, it can be done during the session, but this is session one. The next session you will have with Alison Macmillan in the following week. I believe it's going to be on the 7th of the 10th 2021, where she'll be talking about commando research, who are we, and the importance of research. Thank you very much.